hypothesis testing for mean with small samples. Remember, small samples means or tells you that your in your sample, your number in your sample is less than 30. So what we're going to do with this same stuff we've been doing, again, we're going to use the rejection regions more than we use the p-values. So on this, we're not going to talk about the p-values a whole lot. I'll talk about them a little bit, but with your p-value, remember, you just compare your p-value to your level of significance, your alpha, and you can decide whether to reject or fail to reject the null. But what we're going to use is we're going to find the rejection regions, whether it's a left-tailed or right-tailed or two-tailed, and then we're going to find a standardized score, which is going to be our T, and we're going to decide where that T falls, whether it falls in the rejection region or it falls in the white part, and that's going to tell us whether to reject or fail to reject the null. So what we're doing, identify the level of significance, that's your alpha. Identify the degrees of freedom. Remember, degrees of freedom is just n minus 1. Find your critical values. When you find your critical values, that's what's going to tell you on your thing what this number is right here that cuts off your rejection region or regions. We're going to do that by using table 5. That's the T table or the T chart that you have in your packet there. You figure out your degrees of freedom, n minus 1, and your alpha, and you decide whether you're you look at your HA and you decide whether you're left-tailed, right-tailed, or two-tailed. Remember, that's left-tailed. If your HA has that, it's left-tailed. If it has that, it's right-tailed. If it has that, it's two-tailed. And then we look at that chart and we find this number. Make sure we fix this on your thing. I had it wrong on there. Remember, you're always looking at your alternative hypothesis. Again, if it's this, it's left-tailed. If it's that, it's right-tailed. And if it's not equal to, it's two-tailed. On your critical values, to find your TO, this is the number that's going to go on your picture here. Find the critical value for a left tail, so we're over here. We're looking for this number. They tell us that our alpha is 0.05, our N is 21. First thing we do is find our degrees of freedom. That's just 21 minus 1, which is 20. We use that, this, and the fact that this says left-tailed, but that just tells us that we are one-tailed. And we look on this chart. So you go over in the one-tailed line here and go over to 0.05. And we want to go down to our DF, which is 20. And what's it say?
1.725.
Now when we put this on here, since it's left-tailed, it has to be a negative. So that's our rejection region. And this all just tells us the same thing, negative 1.725. On this one, I think I messed this one up last time. If we're two-tailed, our degrees of freedom here is 25. So we look at two tails, go over to 0.05, go down to 25, and what's that tell us? Nobody can tell me?
2.060.
So 2.060.
Yes.
So this one's a negative on this side, and this one's a positive on this side. Then those, we have two rejection regions. So when we find this time we're gonna be finding a t-value. When we find our t-value, if it falls in one of those regions, then we reject the null. If it falls in this unshaded part, then we fail to reject the null. The t-test, I'm not sure where we left off last time, I think it's somewhere about here, but I'm not sure. The t-test, got to know this formula, that's the formula we're going to use. You can use the formula, or you can use your calculator to find the t-value. We'll discuss that later on. That's what you're testing. That's the standardized test statistic. So that formula there is very important. Did we get this formula last time?
Yes.
We'll get to that. So it's just x bar, same as the formula for the last section. X bar minus mu. For some of you, this is not x bar. This is the mean of the sample, mean of the population, standard deviation of the sample. N is the number in the sample. Our degrees of freedom, again, n minus 1. For anytime we're using t, our n is going to be less than 30. That's what is going to tell us that. So the last section we had z here instead of t. If our n is larger than 30, then we do a z test. If our n is smaller than 30, then we do a t test. Our steps. Again, first step, you got to write your HO and your HA. Step 2, find your level of significance, which is, they're going to tell you. Step 3, find your DF. Step 4, use the table to find your critical values. So you got to find the critical values, and you're also going to, in this class, you're also going to draw the picture. Draw your little graph. Step 5, that just goes along with drawing your graph. Figure out your rejection regions, put them on there. Step 6, find your t-value using that formula. Again, you could use the calculator to find that. We'll talk about that here in a couple minutes. Step 7, make a decision. So 7, you just decide whether to reject or fail to reject the HO. And then the final thing is interpret. Step 8 is just interpret. Remember, with interpret, you're going to have 3 parts to your interpretation. One of them is going to be your alpha, your percentage. The second one's going to come from this chart right here. And the third one is going to tie it back to the original problem, whatever it was. That's the chart. So you just have to remember which one is your claim. You look at one of these 2 columns. If the claim is the HO, and let's say you rejected the HO, then that means you're using that statement right there. If your claim was the HA and you failed to reject the HO, then that's what you put in your interpretation as that second part. So you're using that over and over and over again. I was just looking at the rest of this chapter. There's 2 more sections to this chapter. We're doing the same thing for all these sections. So you're going to be using this same setup over and over and over again. We do this example last time. A used car dealer says that the mean price of a 2005 Honda Pilot LX, and I know this is old, this is 2005, it was supposed to be new. That's almost 20 years ago now. You suspect this claim is incorrect and find that a random sample of 14 similar vehicles has a mean price of $23,000 and a standard deviation of $1,113. Is there enough evidence to reject the dealer's claim at a level significance of 5%? Assume the population is normal. So first thing, and this is all going to be on the next slide, and I'm going to try to fit some of it in here. First thing we got to do, find our HO and our HA. So we read back and we see what this says. It says, the used car dealer says that the cost is at least $23,900. What are we going to do for is at least? First of all, I'll tell you this much. We know it's a mean, so that's going to be a mu in both of those.
So is it greater than or equal to?
So at least means greater than or equal to. So does that go in our HO or our HA? So it's greater than or equal to 23,900. And that's our claim. Make sure you don't forget to show which one is the claim. If that's our HO, what's our HA got to be?
It's going to be less than 200.
So we state our HO, our HA. We find our alpha, that's 0.05. We find our DF. Well, this time our N was 14. So what's our DF? Our degrees of freedom. 13. And we figure out here, I'll draw my little picture down here. We figure out, we look here, and this tells us, are we left-tailed, right-tailed, or two-tailed? So we put a little slash here, shade in that part, and now we got to find this critical value here. And the way we find the critical value is go to our chart, and this time we're using the T chart. So find your T chart. We're one-tailed, so we're using the line across through here that says one-tailed. Our alpha is 0.05, so we go over to 0.05, and our DF was 13, so we go down to 13.
1.771.
So that means our critical value here is, since we're left-tailed, negative 1.771. And I usually put a 0 in here, so just have some reference point. Now, once we have all that, the next thing we got to do is we got to find our T value. And I'm going to show you on your calculator how to find the T value, and we'll also do it out using the formula. Get out your calculators. On your calculator, you go to Stat, then over to Test. So Stat, then Test. The first one says Z-test. We don't want a Z-test for this one. That was last section. This time we want the T-test. So go down to T-test, hit Enter. And you've seen this screen before. We want stats. And then we want to put in our mu. The mu comes from the claim. So this time it's 23,900. X bar comes from our sample. Well, our sample mean was 23,000. So X bar is 23,000. Our standard deviation is 1,113. And what was our N? 14. Then that next to last line, we look right here. Look at the HA, and it's got the less than symbol in it. So that's the one that we want to highlight. So you have to scroll over to it and hit enter, then go down to calculate.
It's the middle.
It's the middle one this time. So then you go down to calculate and you hit enter. Notice it tells you the P value that we're not going to use because we're going to use the rejection regions instead. But the second thing it tells you there is the T value. What's it tell you the T value is?
Which one is
The one that says T.
Oh, -3.02559.
Close enough. So that's our T value. That's what we're going to check and see where it falls here. Now, if we were doing the actual math, doing the formula, which I would normally do the formula because all those buttons that I just had to push are more buttons than have to push to actually do the formula. We do X bar, which is 23,000, minus mu, which was 23,900. Divided by S, which is 1,113, over the square root of 14. So if I grab my calculator, if I'm doing this problem, I can do this top part in my head, that's 900. So I just do 900 divided by, and I put in a parenthesis, 1,113 divided by second square root 14, close the parenthesis and close the second parenthesis, and I get, and I messed it up, but I know what I mean. I get negative 3.025598 something, something, something. Is that pretty close to what we got?
Yeah, and we know since it's September, it has to be negative.
Right. And I should have put negative 900 in because this minus that's negative 900, and I forgot to put in the negative. Then the next thing we do is we look at that T value, wherever we got it from, and we decide where it falls on the graph. Does it fall in the shaded region or does it fall in the white region? Falls in the shaded. So that tells us to reject the null. And then once we know to reject the null, then we do our interpretation. And our interpretation this time is going to say something like, remember it's 3 parts, and it's going to say, with a 5% level significance, there is, then we go to this chart. So with a 5% level significance, there is, the claim was the null, and we rejected it, so we go to this box right here. There is enough evidence to reject the claim of the car dealer that the average price of a 2005 Honda Pilot is at least $23,900. And I bet if we look at all this, this is what it tells us. So we had that, and this was the claim. I don't think I told when I made this out. That's the claim. Make sure you label that. Our DF was 13. We drew our little graph here. Is that what we said? Negative 1.771.
Yeah.
The test statistic, they got 3.026. And actually, again, I messed up there too. That should be a negative. Then our decision, that falls in that rejection region, so it tells us to reject the null. Once we know to reject the null, then we write it out. At a level of a 5% level significance, this is part 1. Then this comes from the chart, this second part here. There is enough evidence to reject the claim that the mean price of a 2005 Honda Pilot is at least $23,900. grade and you handle all that, easy stuff, isn't it? An industrial company claims that the mean pH level of water in the nearby river is 6.8. You randomly select 19 water samples and measure the pH of each. The sample mean and standard deviation are 6.7 and 0.24 respectively. Just means in that order. So the mean 6.7, standard deviation 0.24. Is there enough evidence to reject the claims, the company's claim at a 5% level of significance? So on this one, and I'm going to just do the HO and HA, and then we'll look at the actual answer, just to make sure, because it's where most people getting started, is where most students have the most trouble. It says, an industrial company claims that the mean pH level of water in a nearby river is, so that's equal to, so is that going to be our null or our alternative hypothesis? The HO. So mu equals 6.8, and that's the claim. And what's that mean our alternative hypothesis is? Now the other thing we might do before I show you all the answer here is, let's find the critical value. If we have this, we look at our HA here, that tells us that we are 2-tailed. And to find our critical value, we have our alpha, and we need our DF. If our N was 19, what's our DF?
18.
Then we grab our chart. Remember, we're looking at the T chart. We're 2-tailed this time, so look at that row. 2-tailed. And we want 0.05. And we go down to 18. What's it tell us?
2.101.
Say it again.
2.101.
So negative 2.101 and positive 2.101. Zeros in the middle there. That's our rejection regions. Draw that. And to find the t value, again, we could use the calculator, or we could just calculate it. I'm going to go on to the next slide. So that's that. And again, forgot to put that this was my claim on there. Please make sure you don't forget that. Our alpha was 0.05. Our DF was 18. We draw our picture. Those are our rejection regions. Our test statistic, if I find it using the formula, I come up with negative 1.816. Where does that fall? Does that fall in the blue or the tan? So what's that tell us?
That we failed to reject.
Failed to reject the null. So if it falls in the tan part or the white part, whatever it is, we failed to reject the null. And if we fail to reject the null, our interpretation is going to be with a 5% level of significance. Then we go to this chart. The null was the claim, and we failed to reject it, so we use this box right here. There is not enough evidence to reject the claim that the pH level in that certain, what was it, a stream or something, is equal to 6.8. It looks like I got lazy here because I didn't really explain it real well. I just said that the mean pH is 6.8. Should say something like the mean pH in the stream is 6.8. Again, if when we go to take a test over this, 1, 2, 3 points there. No points there, no points there. Here, probably 2 points. Point for drawing it, point for coming up with the correct things there. Correct critical values, sorry. Your T value, that's another point. Here, 3 parts, so 3 points. 3, 4, 5, 6, 7, 8, 9, about 9 total points for the whole problem. So the really smart thing to do is to just, when you know that you can't do this part, just skip the whole problem, right? Sorry, I'm being sarcastic. To do it on the calculator, again on the calculator, to find the T value. All this is used for is to find the T value. It doesn't tell you like it has in the past, you know, it doesn't tell you your interval or doesn't tell you all the total answer, just to find the T value. Do this on your calculator like we just did, you put in those parts. We always want data, we always want stats. Unless we're putting everything in a list, then you want calculate. Again, I don't ever use that on the calculator, I always just do the formula. It's not that, it's about the same number of buttons to push, regardless. If you know you're messing up the formula, then let the calculator find the T value every time. I don't know, that's up to you. I'm going to skip over this one. Just showing you how to use the calculator, which we just did. You stick all that stuff in, the T value's right there. Again, it also gives you the P value. And if you wanted, you could compare the P to the alpha and decide whether to reject or fail to reject that way. Your calculator will also draw the little picture for you if you want it to draw your picture. I don't know, let's see if we can do that. I don't know how much that screws up the calculator. I never do it because it always messes up the calculator. If I go back to stats, test, all that stuff should still be in there. If I go down to draw instead of calculate, looks like it takes about 5 minutes for it to draw it out. I don't know. It shows the graph, but I don't see the rejection regions. So I don't know if that works or not. I would use the calculator to draw it. This is your assignment. Page 393. Most of these, probably these first bunch here, some silly stuff. Any of them that says something about the p-value, you can use your calculator to find the p-value, then do, if that's what they're asking for. These down here are probably, I wouldn't think all of them, but probably most of them are finding, doing all that extra stuff, all that other stuff that we just did.